Hyperbolic functions feel like they came out of nowhere. What are they even for, and why do they have sin and cosh? Great question. Just like trigonometric functions relate to a circle x superscript 2 plus y superscript 2 equals 1, hyperbolic functions relate to a hyperbola x superscript 2 y superscript 2 equals 1. The h simply stands for hyperbolic. Their definitions are in terms of exponentials. Cosh x equals e to the power of x plus e to the power of negative x, / 2 and sin x equals e to the power of x e to the power of negative x, / 2. So they're like exponential versions of sine and cosine? That's a bit less scary. What about their inverse functions? Exactly. And yes, their inverses are also defined using natural logarithms. For example, arctanh x equals 1/2 ln 1 plus x / 1x. These inverse forms are what you'll typically use to solve equations. Okay, so how would I tackle cosh x equals 2 sin x plus 1 then? You substitute their exponential definitions directly. So, e to the power of x plus e to the power of negative x, / 2 equals 2 asterisk, e to the power of x e to the power of negative x, / 2 plus 1. Multiply by 2, rearrange terms to get a quadratic in e caret x, and then solve for e caret x using substitution like y equals e caret x. So it turns into an exponential equation. What about arctanh x equals ln 2? For that, you'd use the inverse definition directly, 1/2 ln 1 plus x / 1x equals ln 2. Multiply by 2, then exponentiate both sides to get rid of the ln, and solve for x. It becomes 1 plus x / 1x equals 2 squared equals 4. I see the pattern now. It's about converting back to exponentials or using the log forms of the inverses. It's like they're just another language for exponentials. That's a perfect way to think of it. Hyperbolic functions appear in engineering, physics, and even describing the shape of a hanging cable, a catenary curve. They're very practical. So, my action plan is to memorize the exponential definitions and the log forms of their inverses, then practice converting and solving these equations. Excellent plan. And always double-check the domain restrictions for the inverse functions, particularly for arctanh x, where x1.
Enjoying this? Follow Thula Academy for more.
Visit thethula.com to join the world's first virtual campus.